Hello class and welcome to section 9.6, which is exponential growth and decay. 9.6 is our last section in chapter 9, so let's go ahead and get started. Certain assets like homes can appreciate or increase in value over time, while others like cars depreciate or decrease in value with time. So let's go ahead and look at some depreciation problems or decay problems. Suppose you buy a car for $22,000. Okay, and the value of the car decreases by 16% each year. Okay, well, if I have a value that starts at 22,000, that's my A or my principal amount. So that's what I'm starting with. And my 16%, that is my rate. Okay, it says write an exponential equation or function of the form y equals AB to the x that could be used to model the price y of the car. Write the function in terms of x, the number of years since you purchased the car. Okay, so, well, I want to write this equation. So I would have that y is equal to my A value, which is 22,000. And remember I said B was 1 for depreciates minus 16%. Well, I would write 16% as a decimal. So I would go ahead and move it over twice, so it would be minus 0.16 to the x. Okay, so I would rewrite this one more time. So y will equal 22,000. And I would say, well, what is 1 minus 0.16? That's 84. So 0.84 to the x. So there's my equation to model the situation. Then it says, find the value of the car 2 years later, 3 years later, and 7 years later. So this is where you would just go ahead and use your calculator. So for 2 years later, x is the number of years since the car was bought. So you would plug in 2 for x. To the second. And you go ahead, type it in on your calculator. And remember, this is money, so you'd round to 2 decimal places. If you're doing it correctly, you should get $15,523.20. So after 2 years only, you've lost quite a bit of value in your vehicle. 3 years later, same idea. Plug in 3 for x. If I go ahead and do that on my calculator, I will get 13,039 and 49 cents. So that's my value 3 years later. And then lastly, I would do the same thing with 7 years later, plugging in 7 for x. So all this can be done in your calculator. Biggest thing is that you need to know where to plug in 7. And 7 is going to be x because it's the number of years since the car was purchased. If we do that on our calculator, you will get $491.99. So after 7 years, it has lost a lot of value. If you would go ahead and look at that. All right, so let's go ahead and look at another example. Okay, exponential decay. So we have already kind of touched on this. But when a quantity decreases by a fixed percent each year or other period of time, the amount y of the quantity t years is given by. Okay, and we've already seen this equation multiple times. I told you we had y equals ab to the x. The only difference is there you're letting t be time. Okay, so I use t instead of x. And I said before that b is equal to 1 plus or minus r. Okay, well, in this case, when it's decay, you subtract r. Okay, so where A is the initial amount and R is the percent of decrease expressed as a decimal. So you have to make sure that R is written as a decimal. So 1, a cup of coffee contains 130 milligrams of caffeine. If caffeine is eliminated from the body at a rate of 11% per hour, how long will it take for half of the caffeine to be eliminated? It says half of the caffeine. Well, we started out with 130. So if this is my starting out, this is my A. And if I want to figure out, well, half the caffeine, I would take 130 divided by 2, which is 65. Okay, well, that's what we want to know. We want to know what amount. So that's my y value. And it's eliminated at 11% per hour. So my B will be 1 minus 11%, so 0.11, which is 0.89. We know what A is. Okay, A is 130. That's our starting amount. And we know what y is. We know what we want to know. We want to figure out, well, when is y equal to 65? So the only thing I don't know is my t or my x, because we want to know how long and how long is time. So t, I don't know. So let's go ahead and write all this into my equation. So I would have my y, which is 65, is equal to my a, 130, times my b, 0.89, to the t. So we've solved similar problems before, in the sense that we did not know b. So now we're going to, same idea to start solving, is divide both sides by our a, which is 130. Just like when we had to find a b value. So I have 65 over 130. If you type that in on your calculator, it simplifies to 0.5. And I have 0.89 to the t. Okay. Well, I do not know what the variable is for the exponent. So what I need to do is I need to use logs, because the inverse of an exponential is to use logs. So I would take log on both sides. So log on both sides. So I have log of 0.5 is equal to log of 0.89 to the t. Now I remember my rules of exponents. It says I can put that t down in front. So I have log of 0.5 is equal to t times log of 0.89. And now my last step is, if I want to get t by itself, I need to get rid of the log of 0.89. So I would divide both sides by log of 0.89. So t is equal to log of 0.5 divided by log of 0.89. So on your calculator, you can go ahead and type it all in. We would do log of 0.5. Biggest thing is to end your parentheses, divided by log of 0.89. End the parenthesis and hit enter. There is my time. My time is approximately 5.948 years. Or not years, what are we using for time? Hour. So it's a number of hours. So t is approximately 5.948, and it's labeled in hours. So hours. Okay, moving on to example 2. A store is offering a clearance sale on a certain type of digital camera. The original price for the camera was $198. So in this case, that is my A value. The price decreases by 10%, so here's R, until all the cameras were sold. How many weeks will it take for the price of the cameras to drop below half of the original price? Well, half the original price would be $198 divided by 2, which gives me 99. Okay, so we want to know, well, when will it be 99? So my final amount is y, so I'm going to set it up. I know my y is 99 is equal to my amount, 198, and then 1 minus my rate, 10%, which I would write as 0.1, to the t. I would do as I did last time. I would divide both sides by 198. This would be 1/2, if I type it in. 1 minus 0.1 is 0.9 to the t. And same thing as last time. I have a variable in my exponent, and when I do, I would take log on both sides. So I have log of 1/2 is equal to log of 0.9 to the t. Using my rule, I put that t down in front. Okay, so I have log of 1/2 is equal to t times log of 0.9. And my last step is to get t by itself. So t times, so in order to undo multiplication, I do division, log of 0.9. So on my calculator, t is log of 1/2 divided by log of 0.9. Type it in just as I typed in the last one, and we will get that t is approximately 6.579, and I would want this is labeled in weeks, so okay, at least 6.579 weeks. Okay. All right, our next example, example 3. Example 3 is an example of exponential growth. So now the difference between exponential growth and exponential decay is for my growth, my b value is 1 plus r. With decay, your b is 1 minus r. Okay? Growth, it's 1 plus r. So let's just go ahead and look at example 3. In 1910, the population of a city was, 120,000. So that's where I'm starting out. So my A is 120,000. Since then, the population has increased 1.5%. So B will equal 1 plus, and I'd write this as a decimal. 1.5% is equal to, move it over 2, so I'd have 0.015. So plus 0.015, and if the population continues to grow at this rate, what will the population be in 2010? Okay, well now in this case, I don't know my final amount, so I don't know what y is, but I do know what t is. It's the number of years since 1910. So from 1910 to 2010, it is 100 years. Okay, so that's what I would have for t. So now I would write my equation. We don't know y, so y is equal to my a value. Then I would have 1.015 to the 100th. And we can type all of this in on our calculator. And we would get 531,845.4779. Okay, that's what I would get when I type it in my calculator, but we're talking about a population, and you cannot refer to 0.4779 of a person. So using rules of rounding, I would say that it is 531,845 people. So people, you can't have a decimal of a people, and money, you need to only have 2 decimals. So some rounding rules to keep in mind. All right, example 4, same idea, it's an exponential growth. So the population of a city of 1 million is increasing at a rate of 3% per year. So population 1 million, that's my A, increasing 3%. Okay, so if the population continues to grow at this rate, in how many years will the population have doubled? Okay, well our final amount, we want to know what doubles. So we would take 2 times 1 million, which will give me 2 million. So my y is 2 million. My A is 1 million. That's what I'm starting out with. And my B, my rate is 3%. So it'd be 1 plus 0.03. And my time, that's what we're trying to figure out. We want to know how long, how many years. So that's my time. So I would plug everything in. So I have 2 million is equal to 1 million. My B value, 1.03 to the t. All right, now this one is very similar to the first few where we don't know time, so we're going to have to eventually use logs. So first things first, divide by 1 million. My millions will cancel. And all my zeros here will cancel. So I'm just left with 2 is equal to 1.03t. In order to solve this, I would take log on both sides. So I have log of 2 is equal to log of 1.03t. Remember that log allows that t to come down in front. So it's really t times log of 1.03. Next step, I would divide both sides by log of 1.03. So t is equal to log of 2 divided by log of 1.03. And if you type that in on your calculator, you will get 23.450, and this is labeled in years. Okay, so it will double after 23.450 years. All right, example 5, standardized test practice. We have home values. Okay, in Miller Sport, increased by 4% per year. Mr. Thomas purchased his home 8 years ago for $122,000. What is the value of his home now? I would like you to pause the video and do this standardized practice test on your own. Okay, so pause the video and go ahead and do this. First things first is he bought this for initial of that, and this is my rate. And typically home values increase. Okay, so y is equal to my starting value, my rate, 1 plus 4%, to the time, which is 8. Okay, so I can actually just type this one in on my calculator. And when I type it in on my calculator, I get $166,965.42. So the best answer for this one would be C. Okay, so I hope everybody got that one. If you have any questions, please go ahead, write them down. If you want to take a break, now would be a good time to take a break, because then we're going to move into continuous growth and decay. All right, so other models. The biggest thing with these types of problems is that they have continuous growth or continuous decay. So they use E. Remember when we talked about E? E is just a number. Okay, so if we're talking about decay, my model that I use is y equals a e to the negative kt. The biggest thing is if it's decay, okay, you have a negative k. The other one is growth. It's exactly the same equation, but if you notice your k is positive. So if it's growth, you have a positive k. Decay, you have a negative k. So example 6. The half-life of a radioactive substance is the time it takes for half of the atoms of the substance to disintegrate. All life on Earth contains carbon-14, which decays continuously at a fixed rate. There's my keyword continuously telling me I need to use one of the equations that involve E. The half-life of carbon-14 is 5,760 years. Okay, that is every 5,760 years, half of the mass of carbon-14 decays away. So it wants to know what is the value of K and the equation of the equation of decay for carbon-14. So we want to know, we're talking about a half-life. Okay, well, let's just say that we're going to start with 1. If I have one item, if I am talking about a half-life, and I will only have half of it left. Okay, now it's continuous, so my A is 1, so I would have E to the, now it's decay, so I'm going to have a negative K, but I don't know what K is, so negative. And it says it decays half of it away every 5,760 years. Okay, so I'm going to use this to solve for K. So first things first is I would divide by 1, okay, but I don't really have to worry about that, so I'm just going to rewrite it. So I really have 0.5 and typically we'd write the exponent like that. Now, remember, what's my inverse of E? It isn't log, it's natural log. So in this case, I'm going to take natural log on both sides. So I have natural log of 0.5 is equal to, okay, natural log of E to the negative 5,760K. Remember, that allows me to bring this down in front, so I have this in front. Natural log of E. Well, what is natural log of E? It is just 1. Okay, so 1 times that, it will just be left with negative 5,760K. Now the last thing I need to do is I want to get K by itself, so I'm going to divide by negative 5,760. So if I do that on my calculator, K is equal to 0.00012. So that is what K is. All right, so it wants to know what's the equation for decay for carbon-14. The equation for decay for carbon-14 would be that Y is equal to my A amount. A e to the negative 0.00012 t. Okay, so you need to fill in your amount and everything that you have there. But that would be my equation. You are going to need this K value and this equation for your homework. So this is for number 5 on your homework. It's not listed there, so make sure you remember that this is here for number 5. Highlight it, do something special. So you're going to need that for number 5 on your homework. All right, and one last one, number 7. So for a certain strain of bacteria, K is 0.872 when T is measured in days. Using the formula, how long will it take 9 bacteria to increase to 738 bacteria? So let's just write out what we know. We know what K is. Okay, what is it? How long will it take 9 bacteria? What is that 9? That's the amount I'm starting out with. So my A is 9, and we want to know when it increases to. We want to know the amount they have left. So the final amount is Y. $738. There we go. All right, and T. Well, we want to know how long, so that's what we do not know. So we just go ahead and fill in everything we do know. So we know Y is 738 equals A, 9, E to the K, 0.872, then we don't know T. So first things first, I would divide both sides by 9. 738 divided by 9 will give me 82 is equal to E to the 0.872t. Once again, my variable is in my exponent, so I need to get rid of it. So I would take, with E, we use natural log on both sides. So I have natural log of 82 is equal to, remember these are going to cancel, and I'll just be left with 0.872t. And my last step would be to divide by 0.872. So T is equal to natural log of 82 divided by 0.872. And I would type that into my calculator, and I would get that is 5.054, and this is labeled in days. So T is 5.054. So it would take that many days to increase to 738 bacteria. All right, that's going to be it for Chapter 9 and Section 9.6. So if you have any questions, please feel free to write them down. Ask me tomorrow in class. Otherwise, have a great day, and I will see you later.